What's going on, guys? Welcome back to this video. Today we're going to talk about Zeke, and this video is part of the SOC analyst level 1 pathway. Okay, so what is Zeke? Zeke is an open source tool used for something called network security monitoring, or let's say it is network monitoring. Okay, so what do you mean by saying network monitoring? Network monitoring is highly focused on monitoring specific IT metrics. For example, in network monitoring, we focus on making sure that there is maximum uptime of network devices or devices. So the first metric is uptime. The other metric is device health. Now the device can be an endpoint, can be a smartphone, can be a switch, can be a network device, a device that is considered as an IT asset. In network monitoring, we focus on keeping these metrics in line with business objectives: uptime, the device health, also the quality of the connection. So we call it connection quality. Additionally, another thing that falls under network monitoring is the performance. So we use Zeke as a tool or as a network monitoring tool to monitor the network for the uptime, the device health, the connection quality, the performance. We make sure that all the IT assets comply with a specific policy that is determined by your organization. Now, this policy may actually dictate that the uptime for the devices should be 24 hours. The device health should not be below, for example, 80%. The connection quality and the performance of the IT assets like the network devices, the endpoints, the servers. So Zeke can help us actually in network monitoring by what? So Zeke helps you investigate or do two kinds of operations on network traffic: live network capture or live analysis, and the other thing is offline pcap analysis. Thing is with live network analysis, Zeke needs to run as a service. So here Zeke as a service. And when we want to perform offline pcap analysis, in here we run Zeke from the command line. Okay, so now we know why what Zeke is used for and what are the operating modes of Zeke. Let's now discuss the connection of all this with the SOC analysis or SOC analyst. So basically, as a SOC analyst, you will use Zeke for something called the network security monitoring. Network security monitoring is similar to network monitoring, okay, in that you actually monitor live traffic and sometimes perform pcap analysis, but the objective is different. In network security monitoring, what we are actually focused on, we are focused on monitoring the network for example, suspicious traffic, right? We monitor the network for rogue hosts, such as rogue domains, rogue IP addresses, so on and so forth. Additionally, we analyze the encrypted traffic. We also analyze the port usage. We also analyze patterns, traffic patterns. So at the end, Zeke can also be used for network security monitoring, similar to Snort. So remember, guys, Snort is an IPS IDS. Zeek can also be used as an IPS IDS in that it monitors the live traffic or the offline traffic, right? So when we actually use Zeek as an IPS IDS, we can use the live traffic operating mode, okay? And when we do that, Zeek will generate multiple types, or actually many types of logs. In fact, when you use Zeek to monitor live traffic or even to analyze a pcap file, Zeek generates plus 50 types of logs. Imagine the amount of logs Zeek generates. And that's why Zeek is slightly different than Snort. Zeek is really focused on the logs. When you analyze the traffic, Zeek will be able to recognize the traffic and generate plus 50 types of logs so that you can analyze them. But Snort is really focused on, or is more focused on, alerts. So that's the difference between Snort and Zeek. Okay, let's carry over with Zeek. Okay, let's take a scenario. Let's say you are delivered a pcap file from a host that's compromised. Let's say compromised.pcap. And then what you're going to do, you're going to use Zeek in the pcap analysis mode, meaning you will invoke Zeek from the command line, Zeek-C-R, and then you will provide the pcap name. What's going to happen, as we mentioned earlier, when we analyze the traffic, whether live or offline, Zeek will generate all sorts of logs. Okay, so what happens here, Zeek will analyze the pcap file using what's called Zeek engine. And there is another part of Zeek is the scripting engine. So these two engines will be used by Zeek to recognize traffic patterns. Based on the analysis Zeek performed, you will have plus 50 types of logs. But thing is, these logs will be different depending on the pcap or depending on the traffic you are analyzing. For example, Zeek may generate, let's say, these logs: connection log and DNS log, DHCP log. As you can see, these are logs that are protocol dependent. Now let's discuss what are the protocols, or what are the logs that Zeek generates. So overall, guys, again, depending on the scenario, Zeek overall generates many types of logs. First, you have logs that are protocol based, such as these. So if Zeek analyzes the pcap file and determines that the only log that can be extracted from the file are protocol based, you will see these logs. You may see also HTTP. So it is protocol based logs. Zeek may also generate detection based logs. Detection based logs. These logs, an example of these logs can be signature.log. Okay, signatures of known traffic patterns or known malicious files. Traceroute log. I'm trying to be fast when writing, that's why some things appear messy. Notice log. These are examples of logs that are classified under or classified as detection based logs. Another type of log is observation logs. We call them observation logs. These logs can also be generated when analyzing pcap files, or even when analyzing live traffic. Observation logs, an example of observation log is known underscore host. These are known hosts on your network, known services. that's one of the downsides of working with Zeek. You have many types of logs, and with every type of log you have many files that can be generated. Alright, so the next part, now we know how Zeek works and the operating modes of Zeek and the logs that Zeek generates. Now let's discuss how we can analyze these logs. Okay, so now we have the pcap file. Zeek, we run Zeek from the command line, and Zeek has generated now, let's say, connection log, DNS log, JSP log. What's the next step? The next step is to analyze these logs. You have multiple options. Analyzing the logs, first you can analyze them from the command line. Now analyzing the logs from the command line will need skills in Linux. You will need knowledge with file processing commands such as cut, sort, grep. These are file processing commands built in Linux. In order to analyze these logs, you have to open these logs, okay, and you have to recognize the fields. For example, let's say we have connection log. We open the file index editor and we recognize that we have IP field, port field, duration of the connection, right? So recognizing the fields is very important when analyzing the log file and correlating the analysis with other log files. So all of these logs, when generated, will have one common field between them. It's like when you work with relational databases. So here, the primary field or the primary common field is the UID. This common field will be used for log correlation when you do that. Let's go back to the analysis. So here we use cut, sort, grep to be able to process these files and extract these fields. The other thing, or the other option of analyzing these logs, is using Splunk or ELK. Why? Because when you upload these logs to Splunk, Splunk will display these logs in a way that you can analyze them and run queries against them. So Splunk is another option of analyzing these logs generated by Zeek. ELK is another option. At the end, you will be able to visualize the data. Okay, so now we talked about Zeek, the use cases of Zeek, the operating modes of Zeek, the log types of Zeek, of course, in very brief fashion, and how to analyze the logs. Now let's take a practical scenario on how to analyze logs generated by Zeek using the command line. So as a reminder, guys, the lab material of this room is accredited to TryHackMe, and we're doing task 2, 3, and 4. So task 2, 3, and 4 deal with the sample pcap files given in the exercise files directory, where we're going to analyze these pcap files. So first, let's cd to task 2. Okay, so as you can see, we have a sample pcap file and we have log files. For now, ignore the log files. I'm going to discuss how these have been generated. For now, we have a pcap file. We need to analyze this pcap file with Zeek. Remember that in order to run or in order to use Zeek for offline analysis, we have to run Zeek directly from the command line. It means it will not run as a service. So on a separate tab here, let me explain another thing about running Zeek as a service. So here, let me make this bigger. First thing, we run Zeek-v to find out the version of the Zeek, and that's the first answer for the first question. What is the installed Zeek instance version number? Now, in order to invoke or in order to run Zeek as a service so that Zeek can monitor live traffic, you have to run the Zeek control module. In order to invoke the Zeek control module, we have to be in elevated mode, meaning we have to run sudo su. Okay, so now we are in elevated mode. Now we can invoke the Zeek control. We run Zeek ctl, so Zeek ctl, and now we run Zeek as a service. So when running Zeek as service, we have specific commands we can run to make sure that the service is running. We have status, start, and stop. If we type here status, so it shows us that Zeek is running. Now if you run start, we can start the Zeek, and then we can run status again. So right now it is running. Before it wasn't running. Right now it is running, and this is the uptime. We can stop the service by typing stop, and now we stop Zeek. That's how we use Zeek for live traffic analysis. So once Zeek is running as a service, it will monitor the live traffic and it will generate logs. But where Zeek will generate the logs? Usually Zeek will store the logs under opt Zeek logs. That's the default log path when running Zeek as service. But today we're going to run Zeek against specific pcap files. Okay, to do that we have to use Zeek. So here -c -r and the sample pcap file. -r for the reading option to process the pcap file, -c to ignore the checksum errors. So we use Zeek -c -r sample. And when we do that, Zeek will analyze the pcap file using its own engine and will generate these log files. Take a look at these log files. All these log files that have been generated are protocol based. NTP, DNS, DHCP, CON, SNMP, SSH, syslog. All of these are protocol based. Let's see the question. Next question. What is the version of the Zeek control module? Here we can extract the version Zeek control module from here. So Zeek control is 240. Investigate the sample pcap file. What is the number of generated alert files? So here we run Zeek against the pcap files, and we see we have generated 8 type of logs or 8 alert files. 1, 2, 3, 4, 5, 6, 7, 8. That's the answer for this question. Now we go to the next task. We analyze more logs. So we're going to go to task 3. Alright, so same thing. We're going to run Zeek against the sample pcap, and it will generate these logs. So investigate the sample pcap file. Investigate the DHCP log file. What is the available hostname? Okay, so we have this log file. We want to extract the hostname. Remember that we're analyzing the logs from the command line. We're not using Splunk or ELK. So here we have to rely on our Linux skills. So cat, first we view the file. Imagine file, this file is small, but for large pcap files, you will see like lines, thousands of lines of entries. So we're not going to be able to analyze this file this way, but here we want to take a look at the fields. Take a look, we have these fields, the UID, the client address, the server address, the MAC, the hostname. So here we want to take a look only at the fields. We don't want to look at the numbers. Because remember, again, in real scenarios, you will have a lot of data to read. You're not going to be able to read them directly from here. So first, we will take a look at the fields. Next, we see the question is asking about the hostname. So indeed, guys, we have a field named hostname. So we want to extract the hostname. What we're going to do, we're going to use a tool called Zeek Cut. So Zeek Cut helps us to analyze these logs. So how to use Zeek Cut? We're going to first cat the file, which is DHCP, and then we pipe it to Zeek Cut. And then we provide the field name. The field name is hostname, host underscore name. As you can see, Zeek Cut has extracted the values under this field. We have 2 values. What if we want them only one value? We want to eliminate the duplicate entries. So we're going to pipe this again to sort. Okay, or we can use unique. So unique will eliminate the duplicate entries under the hostname field. And we got only the hostname. Investigate the DNS log file. What is the number of unique DNS queries? All right, let's take a look at the DNS log file. Again, as you can see here, we have a lot of entries. We're going to take a look at the fields here. So let's see. Yeah, from here. So I have the UID, the origin address, the origin port, the destination address, destination port, the protocol, transaction ID. So we don't have a field that specifically tells us the number of queries, right? So what we have to do, we have to rely on a certain field and remove the duplicates. For example, one way to recognize how many queries is to rely on the origin IP address here, right? So the origin IP address here, as you can see, indicates how many DNS queries. If we can extract the IP addresses that created the DNS queries, we can tell how many DNS queries that have been generated. But we have to take into consideration to remove the duplicates. Let's do that. So cat DNS Zeke cut. The field we chose is id.origin. So id.origin _h, and then we're gonna pipe this to unique. See how many unique IP addresses we have? As you can see, we have only 2 unique IP addresses, which means that we have 2 unique DNS queries. Answer is 2. Investigate the connection log file. What is the longest connection duration? So cat connection, we take a look at this and we see if there is a field that represents the connection duration. See, this file is kind of big, so to do that effectively, to load a huge file, it's better to use head -n10. So we display the first 10 lines. As you can see, we have only the fields here. So we're going to see here if there is duration. As you can see, we have a field that represents the connection duration. Simply, it is named as duration. So cat connection log Zeke cut duration . Okay, so we're asked to, as you can see here, the longest connection duration. So first, let's display these durations. So these are the connection durations. As you can see, they are not sorted. In order to extract the longest connection duration, we have to sort them. We can sort them either in ascending or descending order. First, let's eliminate the duplicates. So we use unique. Okay, and then we're going to say sort -n. All right, so here we sort them in a descending order, as you can see. So the longest connection duration is this. Alternatively, you can reverse the order of the sorting by running or by adding R, so it becomes sort -rn. So here we reverse the order, and now it is in a descending order. That's the longest connection duration. Now, for task 4, there is no questions to answer, but here it displays the most used, file processing commands in Linux in order to help you analyze the logs more effectively.